Welcome to the VST Electrical Contractor training for the installation of the U.S. version of the Green Machine. We'll be covering how to complete the electrical installation of the Green Machine. This subject is covered by Chapter 3 of the manual that accompanies the Green Machine. But before we begin, here's a quick overview of the Green Machine. The Green Machine allows a GDF to capture, control, and monitor fugitive emissions to improve air and water quality. In short, when the Green Machine turns on, it pulls a vacuum on the underground storage tank and then pushes this hydrocarbon-infused vapor through an advanced filtration system. The air that comes out the other side of the filter is clean air and is vented to the atmosphere. The hydrocarbons that were filtered out are then returned to the underground storage tank. In this illustration, you can see the various systems that the Green Machine must be connected to if it is to work correctly. Note that there is both an outlet and a safety disconnect switch near the Green Machine. These will come in handy for any testing and maintenance that might be done on the Green Machine. Safety is always a primary concern when performing an installation on a GDF site. The area under the Green Machine cover is a Class 1 Division 2 area. Because of this, installation must comply with various safety codes, such as the NEC, as well as federal, state, and local codes. Also, take special care when working in an area where vehicle traffic may occur to protect yourself and others. In this training, we're going to cover 3 points listed here. 1. Pulling wires from the data hut to the Green Machine area. 2. The proper way to wire each of the components in the Green Machine system. And 3. Proper labeling of the electric panel. Here is a high-level view of the electrical system involving the Green Machine and its control panel. The dashed line here represents the wall of the GDF data hut. Everything above this line is inside the data hut, while everything below this line is outdoors. There are 8 components within the electrical system. Number 1, the VST control panel. The control panel is the center of our electrical system and ultimately determines if the Green Machine should power on or off. An important system for the VST control panel to be connected to is number 2, the emergency shutoff or ESO. When this system is activated, the entire GDF loses power. This connection ensures that the VST control panel and in turn the Green Machine will lose power when the ESO is activated. The next system is number 3, the fuel management system, usually a Veeder-Root TLS 350 or 450. This system is sometimes called the tank sensor. In the event of an overfill, this system will send an alert to the VST control panel. This will in turn deactivate the Green Machine. If the fuel management system is not correctly connected to the control panel, then the Green Machine may ingest liquid which will ruin the vacuum pump inside. Number 4, the main electrical panel powers the VST control panel on a 20 amp breaker and also powers number 5, a 120 VAC outlet, which is to be installed outside near the Green Machine. This outlet will be helpful in any testing and maintenance that will be required to keep the Green Machine running in good condition. This outlet, along with number 6, the safety disconnect switch, should be placed in close proximity to the Green Machine. The safety disconnect switch, when engaged, will cut power to the Green Machine. This will allow for safe testing and maintenance to be performed on the Green Machine. Number 7, the Green Machine is a vapor processing unit. The first step to installing the Green Machine is pulling wires from inside the data hut to the Green Machine area. Number 8, the dispenser shutdown relay. The dispenser shutdown relay only applies to the CS8 installation. The dashed line here represents the wall of the GDF data hut. Any lines that pass through this dashed line need to be pulled out to the Green Machine area. A total of 12 wires and 1 cable must be pulled. These wires can be pulled through either flexible or rigid conduit. The first set of 3 wires powers a 120 VAC outlet to be installed near the Green Machine. This outlet will be used for testing and any maintenance that requires a power source. Here's what the outlet will look like after it's been installed correctly. The next group of wires that need to be pulled is the 9 wires and 1 cable from the VST control panel to the green machine and safety disconnect switch. Both the green machine functional and safety disconnect subsets of wires are to be run through a gang box. Here's a breakdown of what wires go where. All of the terminal blocks inside the VST control panel and junction box are labeled with the corresponding wire identifier. The 6 wires that control the green machine and the 1 cable that controls the pressure sensor all go into the bottom of the junction box. All connections within the blue box are on the top of the terminal blocks and come pre-wired from VST's production facility. The electrical contractor is only responsible for terminating wires to the bottom side of each terminal. Next is the safety disconnect switch. These wires should be pulled out to a gang box along with the 6 functional wires and pressure sensor cable. The safety disconnect switch wires must be separated from the other wires at the gang box and run to the switch, which is to be installed near the green machine. The safety disconnect switch is a safety feature for anyone performing maintenance or testing on the green machine. When this switch is tripped, the green machine receives no power. Here's an example of a properly installed safety disconnect switch. Next, we're going to discuss the 3 wires that must be run between the VST control panel and the emergency shutoff, or ESO. The ESO circuit is usually part of a shunt circuit and must be wired as such. The VST control panel must receive its power from the ESO relay circuit. The emergency shutoff relay is located in the power box. Here's a picture of the inside of the data hut. Note the VST control panel on the right and the power box on the left. Highlighted here in red is a potential path the wires can be run along. The emergency shutoff system has the ability to cut power to the entire GDF. The ESO circuit to the VST control panel must be installed for the VST control panel to have power to operate the green machine. It is required that the VST control panel and in turn the green machine also lose power when the emergency shutoff system is activated. Next, we'll discuss the 2 wires that form the connection between the VST control panel and the fuel management system. These wires must be shielded. This connection alerts the VST control panel when an overfill condition exists. The VST control panel on the right must be connected to the fuel management system on the left. In this example, the fuel management system is a Veeder-Root TLS 350. The 4 relay module within the fuel management system will be programmed by the startup contractor. The connection to make is between the electrical panel and the ESO relay. This is the connection that powers the VST control panel. The size breaker required for this connection is 20 amps. The final connection to make is between the dispenser shutdown relay and the VST control panel. This connection only applies to CS8 green machine installations. When this connection is made, the VST control panel has the ability to stop the station from dispensing fuel. The relay must be installed in line with the dispenser relays, with the incoming power routing to the top of the relay. The power circuit is completed by connecting the bottom outputs of the relay to the dispenser relays. The connection to the VST control panel is made on the remaining 2 contacts with an external 120 VAC power source on the 02040 wire and the 02050 wire returning to the VST control panel. You have reached the end of this video.